My name is Ben Starkey, and today I'll be talking about Physics 2212 Lab 1 Charged Tapes. So a brief introduction. The purpose of this lab was to study the electric field and electric force and compare those with the gravitational force. Some constants I'll be using throughout this presentation are K equals 9 to the 9 Newton times meter squared per Coulomb squared, and E equals 1.6 to negative 19 coulombs. So the charge of an electron is negative E, and the charge of a proton would be positive E. And the result of this experiment was balancing the electric force and gravitational force and calculating the charge needed to balance those two forces. So we can model the force of gravity as negative mg near Earth's surface, and the electric force is down on the bottom left here, which is Coulomb's constant times the two particle charges divided by the radius squared. And we can see the relationship between the electric field and the force, because the electric field would just be the force divided by one of those point charges, and so that would give us E equals K times point charge divided by radius squared. So to talk about the experiment, we started with two pieces of tape on top of each other, and one of the tapes is labeled U, which is the upper tape, and we quickly ripped off that U tape to strip electrons off. And this left the bottom tape negatively charged and the top tape positively charged, and we determined that the top tape was positively charged after rubbing a pen on our clothes to make the pen negatively charged, and these two were attracted, meaning and opposites attract, so it had to be opposite of the negatively charged pen, making it positive. So the main experiment was we brought that bottom upper tape close to a suspended upper tape until the upper tape was equal, which meant that the electric force and gravitational force were equal in opposite directions, having the net force be 0. And so we had to model these tapes as point charges where all charge was located right in the center. And so then the distance between those two that we found was 0.008 meters. So the results from the lab, we came away with 4 measured values from the lab, which were the mass of the tape, the length of the tape, the width of the tape, and then D, the distance between the two tapes. And all these, the mass, length, and the width, are with respect to the top tape, as that's the one that we're really studying. So our calculated values, we found the force of gravity on the tape, which was just mg near the Earth's surface. So we found that to be 1.32 to the negative 3 newtons. And we used this to solve for Q using the force electric equation as well. So we set those two equal to each other because the sum of the forces was 0. And we were able to find Q from that after rearranging the equation and plugging in our values, which gave us 3.07 to the negative 9th coulombs was the charge for a single point charge. And we were able to find the number of electrons either gained or lost, and because it was positive, we knew that this was the electrons lost, so we divided that charge by the amount of charge per one electron, which gave us 1.9 to the 10 electrons lost. And then we used the area of the tape and the area of the atom by just multiplying the dimensions to get those areas of both. And we were able to find the number of atoms by dividing those two areas, which gave us 2.7 to the 10 atoms. And so then we could find the ratio was the number of electrons lost divided by the number of atoms, which gave us 7.1 to the negative 8th, and that was electrons lost per atom. Then talking about my coding. So here is, you can see my computer visualization. The yellow arrow is electric force, the red arrow is gravitational force, and then those two red spheres are the tapes modeled as point charges. And then you can see my calculations on the right there. I have mg, the charge of a single tape, electron deficiency, and then the vector electric force. And it's just important to note that mg is equal to the magnitude of the electric force here because the sum of forces is 0. So some simplifying assumptions in my calculations was to ignore air resistance. We did treat the tapes as modeled as point charges, where each point charge had the same magnitude of charge evenly distributed all across the tape. And so these assumptions did lead to some experimental error, but for our purposes, it was negligible. So some conclusion questions are: if electrons had positive charge instead of negative charge, really not much would change. The two tapes would still repel each other because like charges repel, but the electric field direction would differ, but we didn't do too much with the electric field, so not much would change in this experiment. And handling the charged objects more makes them lose their charge faster, and so you really don't want to handle the tapes much at all, as they'll become neutral faster and it'll be harder to see the balance of the forces. So thank you for listening.